In this video, we're going to have a look at moment about an axis, and this is coming off the back of the last video that I've done. So let's get into the video. So say we have the position vector of a point from the origin given as, let's use r again, so r equals 2i plus say 1j, and let's use 3k this time. And because this is a position from a point, its unit will be in meters. Now we are going to have some force acting at the same point. So force that will be acting at that same point A will be, let's use some easy numbers this time. So 10i plus 20j and plus say 30k. And because this is a force, we are going to use Newton as our unit. Now, what we're going to determine is the moment of the force about point O, which is the origin. So remember that R is given as a vector from the origin to the point 2i, 1j, 3k. And we're going to also find the moment of the force about the, let's use the z-axis passing through 0. And we're going to also look at the direction of the moment about the axis. So quite a few bit, but I promise by the end you will understand every single bit of the calculation. So for this calculation, we're going to start by writing the moment equation. So moment here is going to be R times F. So whenever we need to find the moment of a force in 3D, a good place to start is where we are now, which is to looking at the cross product, in this case cross product of R and F. And R is the position of the point where the force acts, and F is the force itself. So let's see how we will write this out now. So I'm going to take a slightly different setup to the first video that I've done, and it's just so you can see everything in one go. So first of all, we're going to write this out in matrix form. So M is given then as I, J, and K. And I'm going to use the coefficients of I, J, and K for R, which are 2, 1, and 3. And then the coefficients of I, J, and K for our force, which will be 10, 20, and 30. And then we're going to get now into the setup of our equations. So for M equals, we're going to write out the coefficients first of, let's start with I. So the coefficients of I. And what we have to do here to get the coefficients of I, we're going to look at the row and the column that the I is contained in, and we're going to eliminate those members or elements. So if we go across I, J, and K, all of those in the same row as I, and if we go down, we have the 2 and the 10 in the same column as I. So those will be eliminated, and what we're left with is this 2 by 2 matrix, which is going to be just 1, 3, 20, and 30. And then for J, we have to start with minus J. I did say I'll do a video on why that is so, and I'll definitely cover that. So just look out for that video. Now for the J, we're going to do the same thing. So we're going to cross out the elements that are in the same row and column as J. So if we cross out our I, J, and K and cross out that column, then what we're left with for the J is the determinant. So that's what these lines mean. So the determinant of 2, 3, 10, 30. And we're going to repeat the exact process to get our K value. So now we're going to have plus K, and it's the same thing. So we just eliminate the 3 and the 30 there. So we're left with 2, 1, 10, and 20. And I'm going to show you now how to do the calculation for each of the components. So let's get into those calculations. Okay, so this is what we have left. And so for each of these, what we're going to do, I'll just color code it in one go so you can see what we're going to multiply. We're going to multiply the leading determinant, which I'll color code in blue, across there, and across there. And we're going to multiply non-leading, so we go across like that, and like that. So let's get all the calculations done now. So for the I, we do the blue bit first, so that will just be, let me just write I component. So that's going to just be 1 multiplied by 30 and minus 3 multiplied by 20. So 1 times 30, so that's 30 minus 60. So this leaves us with negative 30. So therefore we have here negative 30i. Going for the j components now. So for the j components, more of the same. So we multiply the leading, which is the blue, so 2 times the 30 there. So we have 2 times 30 and minus the green bit, so that's going to be 3 times by 10. And this is going to give us 60 take 30, which is a positive 30. However, remember that the j is negative, so we have a preceding sign there for the j, which again I'll get into that bit in another video. So we have negative 30j for this one, and we're going to do the same thing now to get the k components. So k components, and it will appear as if I'm getting 30 for all the answers here, but it's just to really show you the process. So it doesn't matter what numbers we use, it's the same process. So for this one then, it's going to be 2 multiplied by 20 and take 1 multiplied by 10. And this gives us a positive 30. So therefore we have 30k. So finally, we write the full vector now for the moment. So m, our result for the cross product, is minus 30i minus 30j and plus 30k. And from this we can now extract the answers that we're after. So if we were to extract the moment about the z-axis, because that was one of the questions that we had earlier, these are effectively x, y, and z. So the moment about the z-axis, I'll just write mz for moment about the z-axis, would just simply be 30 Newton meters for that one. In terms of its direction, it's positive, so that's it. So it just tells you which direction we're in because it's positive. If we were to do the y, then it would be similar. It would just be negative 30, and that's really it. So I hope you have enjoyed this video. We're going to continue in this static series. I hope to do up to 100 videos of just statics, and then we move on to other areas. But definitely this will be a solid growing library of content that you can use for years to come. And I'll see you in the next video.